Okay, for those of you that don't have calculators at home, I'm going to show you how you can use an app called Desmos, Desmos, in order to answer free response questions and multiple choice questions for the AP exam. Now, unfortunately, Desmos cannot be used on the AP exam, but while you're at home just doing homework, this is something that you can utilize in order to help you. So I'm going to illustrate this using 2013 ABBC problem number 1, which was a calculator problem. And so if you want to just look through that problem real quick on what all we're going to have to do here, we're given a function g of t, which represents the rate at which unprocessed gravel arrives at a processing plant. And then in the last sentence, we're told that the plant processes the gravel at a constant rate of 100 tons per hour. So that's our out rate. And so just to take a quick look at this problem, part A is going to want us to find a derivative of g at time 5. Letter B is going to want us to find an integral of g of t from 0 to 8, since it's asking for the total amount and we're given the rate of change. Part C is going to want us to compare the rates to see if the amount is increasing or decreasing. So we're going to have to evaluate g of 5 and compare that with 100 in part C. And then part D is our candidates test, where we're wanting to find the maximum amount of unprocessed gravel, which means we're going to have to solve an equation and then do a candidates test. And Desmos is able to do all of those things. So let's jump over to Desmos right now. Desmos is right here, this green icon that says Desmos. There's also the one right next to it. I don't know if you can see that on the third row down on the far right. Test mode. You can use that also. It doesn't really matter, but I'm going to use this green one just to illustrate what's going on. And so you can see that I've already typed in these functions into the grapher here. G of t is equal to, and then I just used P of t is equal to 100. I think I used P for processing. So I have that in my second line here. So in part A, we want to find g prime of 5. And I just want to show you how easy this is. If you just come down to the third line and then type in g and then prime as the little apostrophe and then parentheses 5, it will tell you immediately what g prime of 5 is right here, negative 24.5875, and then you can jump into your explanation that goes along with part A. In part B, as we said, we wanted to do an integral. So to do an integral, you can just hit enter to come down to line 4 here and just type in INT, and it will automatically pop up an integral sign for you, and you can type in here 0 to 8, and then arrow over to the right, and then put your function g of t. Now, it's not going to do anything until you put the differential dt. So for those of you that like to leave that off on your papers, Desmos is not going to let you do that. You've got to put that dt in there before it'll give you the answer. And so you can see there, it's real easy. It gives you the answer, 825.5510. Okay, so once again, in order to do that, just back up real quick in case you missed it. INT is all you have to type, and then you're able to do an integral. And you can do an integral of anything. You can do 0 to 2 of x squared dx if you want to, and that will also give you the answer just like that. So very nice functionality here in Desmos. Now in part C, as we said, we're trying to compare the rates, and so what I need to do in part C is I need to evaluate g of 5, and that is as easy as just typing g of 5, if you can do it correctly, and then getting the answer, 98.1407. In part C of the calculus there, you would compare that to 100, and so since the rate that the gravel is arriving is smaller than the rate that we're processing, then the amount of gravel is decreasing. And it's literally as easy as just typing g of 5. Now, in part D, that one's a little more tricky to do on Desmos, but we're going to do it exactly the same way we would do on the calculator. So I'm going to delete out what I've got in here, leave my two functions in here, and so I know that I would need to figure out where the rate in equals the rate out in order to find my critical points. And so as you can see on my graph here, I don't have anything going on because there's nothing in this window range. Now, if I were to pinch the screen here, you'll be able to see these two graphs. Now, we need the critical point on a specific interval. So if you'll go to the little wrench up in the top right-hand corner, this will help you set the window range. So on the x-axis, I want the x-min to be 0, and I want the x-max to be 8. And so now I can clearly see what I need to see. And you can change the y-axis as well. So you could change this to be 99 and 101. That way you're looking right at 100 right in the middle of the screen there. And then to find the intersection, you just tap on the point right there, and it tells you the critical point is 4.923. Now, normally we don't want to round that number, and that's not enough decimal places for the AP exam in order to get our answer to be accurate enough. But for our purposes, since we're just at home practicing, this will be fine. 4.923 is going to be enough decimal places. And so what you can do if you want to is you can store that number and put 4.923 right there. Don't mess with anything underneath that number. You can just leave it there as your stored critical point. And then what you can do is, as we would typically do, you can write your amount function here, and tailoring this to this particular problem, we would have 500 plus the integral from 0 to t, and then open a parentheses, and we want to do g of x minus p of x dx. And so now what I can do to run my candidates test is I can say, okay, what is a of 0? And it's not telling me for some reason. This was working earlier, so I'm not exactly sure what I did wrong. It may have been because I'm using a and a twice. Yeah, that's C. So, and I'm learning as I go here. You've defined a in more than one place. So what I need to do here is I need to either change this function to something else or just change that letter to b. And so there you see, now it'll tell me a of 0 is 500. It can tell me a of b is 635.3761. And then evaluating at my other critical point, a of 8, it can tell me 525.5510. And so you can see the maximum occurs at time B, 4.923, and the amount of gravel is 635 tons. So hopefully this video has been helpful. If you guys have any questions, please feel free